Hello. Unit. Oh gosh, I lost count.
9. 10, 11.
Yeah,
Wait,
yeah. There's
again.
only 11 using 9. 9/11ths of the course.
6, 7, 8, 9.
So we're hitting up a unit called oxidation and reduction. We're going to refer to it as RedOx.
RedOx.
All
That's
the
slang.
time. RedOx, RedOx. It's slang. And in this unit, we're going to be reviewing some concepts about charge cancellation technique,
Yeah,
assigning oxidation numbers.
We definitely did that in atoms and bonding.
Yeah, and the reason why we're going to be hitting that stuff up again is because we're going to actually watch how the electrons transfer between elements this time around. Instead of saying, yeah, it's transferring, we're going to look at it and see what kind of chemistry we can do that, like batteries and stuff.
Yeah, sorry, I got crazy there, but
It's cool.
Themes and EQs real quick. Please, first homework video, it's easy. Let's get some credit. We're going to learn a little bit about how do oxidation numbers change in specifically single replacement reactions. So from the reactant side to the product side, the same atom, the charge is going to change.
Right, because some electrons have been lost or gained, and that's what we're going to be tracking. How does a battery turn this chemical energy that's stored up into it into electrical energy? Well, it has to do with the transfer of electrons.
Oh, wait a minute.
What?
We're not supposed to answer these questions.
Dang. I forget that. I didn't say nothing.
Real world application. Here we go. Whoa.
Too fast.
Can electrical energy cause a chemical reaction to occur?
Don't answer, Monaco. Okay.
Yeah, Monaco.
What makes a single replacement reaction spontaneous or not?
Ooh, spontaneous. I like
New
that
word for the unit.
Yeah, we gotta put that on vocab for next year.
Yeah.
What happens in a single replacement reaction?
What really happened?
Yeah, well, we've actually studied single replacement reactions, so we're doing a little review.
Yep. How do you build a battery?
Yeah, I'm not going to give you the answer to this, but one thing I do want to make sure we remember is 2 years ago, our students got hung up on this because the battery that was on the test had a potato in it. Remember, and it floored them because it wasn't a beaker.
Because we were showing our kids actual chemical batteries and how it works in a chemistry lab, and then they throw a freaking potato on the test.
Yeah, it was really
I was
weird.
so angry.
Yeah, the
So
same
angry.
stuff. So this is what you will be able to do.
Yep.
When we drop the mic and you're all done with this unit.
Assign the correct oxidation numbers to ions within elements and compounds.
Right. Some of those atoms have multiple choices, and that's what we have to have a method to make sure we get the right one. Whoa, this thing's fast today.
Yeah.
Touchy. I can identify the oxidation numbers that change after a single replacement.
You're going to need
how
that
they
to
can
go.
change.
We're going to need that in order to draw half reactions so that we can draw the chemical reaction that a battery uses.
Right.
And that's why you have to be able to do it.
Right, and that's the actual real way you balance equations, honestly, with electrons, right?
Identify and write oxidation and reduction half reactions, just like I said, to show the movement of electrons, because when electrons move, physics, they can do work. And that's what a battery is doing. It's providing electrons' potential differences to do work.
We need to figure out what the oxidizing or reducing agents are. This one is kind of a hang up, but let's just make a quick analogy. If you were a professional football player and I was your agent, he'd be on the field and I wouldn't.
Right.
I would represent him.
Right.
So there's a relationship. I'm hoping that analogy is going to help a little bit. No, weak?
Weak sauce, bro. But we'll get there. You'll see it.
It's
a tough one, but
it is a hang up.
We'll teach you. Use Table J, the activity series, which has been like throughout the year. We keep hitting the activity series again and again and
This
again.
will be our third time looking at it?
Yeah, for a different purpose. But we're going to use it this time to predict if a reaction will be spontaneous or not.
Yes. Ooh, spontaneous. Whoa. Some of my students were spontaneous today. They cranked through the first total.
Without any background information?
And without me telling them to.
That's awesome.
I can identify all the parts of the reaction, parts and functions within an electrochemical cell. We got to be able to label that thing up. First, what is an electrochemical cell?
Yep.
And then what are all the different parts?
Yes, and they're batteries. But anyway, in relation to that electrochemical cell, you need to be able to tell me the direction that electrons are flowing through that electrochemical cell. Are they going from the left to the right or the right to the left? And then write the redox half reactions that are happening in each half of this battery.
Yeah, they generally happen right underneath each cell, and you can see which reaction is happening in this beaker, which one's happening in the other beaker.
Yeah.
There we go. One last one. Identify the function of a power source in an electrolytic cell.
Which is different than electrochemical cell.
Right. Electrolytic cell is non-spontaneous.
Right.
So we need to zap it to make it go.
So a little preview. Batteries are electrochemical cells because they use a spontaneous chemical reaction to make electricity. When you have to recharge your battery, it's going to function like an electrolytic cell because you're forcing the reaction to go backwards. You're using the electricity to reset the chemical reaction. So we're going to hit up batteries. So if you've ever wondered how a battery works, because they are just like
Little
cases with pluses and minuses on it.
They
I don't
are
know.
chemistry in action. There is some
For sure.
chemistry going on.
So this whole unit is really in service of getting to that point where you can understand how the basics of batteries work.
Right. There we go. There's our list.
Assignments. I don't think we added anything to it this year. Let me see how many labs we got here. Just one.
Yeah.
Building batteries.
Yeah.
Hopefully they work. A couple of years ago, I had my kids link a whole bunch together in series and actually lit up some LED lights.
Yeah. The only thing we could do if we had one of those voltmeters, because you have them, I don't, is test different metals for electrodes. And then
do a little inquiry.
Yeah, that would be cool.
That would be great. Basic chemical cell, which ones produce the most potential difference?
Yeah.
Magnesium, copper, zinc. There you go. Got 3 options.
Yeah, that would be cool if we could do that. We'll see how it goes.
I'll write it into the lab.
We did lose some days, so we'll see how it goes. But hey, that's all.
That's all. I can stop the playing any night.